Let's briefly talk about some of the infrastructure issues when running Python. First, let's introduce the concept of name resolution. Name resolution is the process of determining the value associated with an identifier. Whenever an identifier is assigned to a value, it happens within a scope. The top-level assignments are typically made in what we call global scope. On the other hand, assignments made within the body of a function typically have a local scope. That is, the scope is local to a specific function call. For example, if the assignment x equals 5 happens within a function, then it has no effect on the identifier x in the broader scope. Each distinct scope in Python is represented with an abstraction known as namespace. A namespace is used to manage all identifiers currently defined in a given scope. The way Python operates is to create its own dictionary that maps each identifying string to its associated value. You can call the functions dir or vars to check the identifiers used in the most locally enclosing namescope. Let's introduce another important concept, first-class objects. Essentially, they are instances of a type that can be assigned to an identifier, parsed as a parameter, or returned by a function. All the data types we introduced earlier in this video series, as well as functions and classes, are first-class types. For example, we can assign an alias to the function print, say scream. We can then call the function scream just like the way we use function print. Now, we are ready to introduce modules and the import statement. In Python, there are more than 100 definitions of functions and classes defined in Python's built-in namespace. What makes Python extremely attractive is the fact that beyond these Python's built-in functions and classes, there are thousands of other values, functions, and classes organized in additional libraries. These libraries are known as modules, and these modules can be imported from within a Python program. Let's look at the following example. From the math module, we import pi and function sqrt for square root. This import statement loads the definitions of pi and sqrt from math module into the current namespace. Let's say we want to print out the value of pi and the square root of 8, and we can get it done just like this. There are some other ways to access definitions from the same module. For example, we can try from math import asterisk. The asterisk is a wildcard indicating that all definitions from the module are to be imported. Use this with care. Another way is import module. In our example, it is import math. This will add the identifier math to the current namespace. And the modules are also first-class objects in Python. So when we import the math module this way, we need to do the following to call the value pi and the function sqrt. math.py and math.sqrt. We can see that in this example when we try to print out the value of pi and the square root of 2. It's rather convenient to create a new Python module of your own. You simply put the relevant definitions in a file named with a .py suffix, just like how you create a Python program. And these definitions can be imported from other .py files within the same project directory, just like how we import math module. We need to be a little careful here. Top-level demands within the module source code are executed when the module is first imported. This is important because, more often than not, you have testing code embedded in your module scripts, and you really don't want to see these testing codes being executed every time you import this module. To deal with that, Python has a special construct for embedding commands within a module that will be executed if the module is directly invoked as a script, but not when the module is imported from another script. Such commands should be placed in the body of a conditional statement if name is equal to main. Here are some useful existing modules that come with the standard Python distribution. They include the math module, which we used a moment ago. Let's take a look at the random module. This table summarizes some useful random functions available in the random module. The function random itself returns a pseudo-random floating point number between 0 and 1 with 0 included and 1 excluded. And rand int of a, b returns a pseudo-random integer in the closed interval a to b, and choice returns an element of the given sequence chosen pseudo-randomly. Let's give some of them a try. We first import 4 functions from the random module. We want to randomly generate 5 numbers between 0 and 1, 5 integers between 0 and 10, and 5 letters from the string A, B, C, D, E. We run a for loop, and here's what we got. In the end, let's try the function shuffle. Suppose there's a list instance of 5 integers 1 through 5, and we want to randomly shuffle the list. Simply throw this list into the function shuffle, and this time we end up with 5, 1, 4, 2, 3.